In today's tutorial, we'll walk through creating a scene with a series of nested shapes using instancing. The focus here is going to be on building the scene, so we aren't going to get into the theory and mechanisms involved. If you're interested in that stuff, check out the videos in the RayTK intro series. We'll be using RayTK version 0.33, so make sure you're using at least that version. Check the video description for a download link. Start by dropping the toolkit talks into your project. I like to do that at the root outside of the main project comp, but you can put it wherever you like. We'll start by setting up the renderer. Open the palette with the Alt-R shortcut and create a RayMarch Render 3D. Then create a null top connected to the first output so you can see the rendered image. With the renderer selected, open RayTK's Editor Tools menu with Alt-Shift-R. Under Add Camera, choose Look at Camera. On the camera, increase the FOV angle to 60 and set the position to 0, 2, and 5. That gives us a view that's a bit wider and slightly from above. Select the renderer again and open the Editor Tools again with Alt-Shift-R, and then under Add Light, I'm going to choose Point Light. On the light, let's set the position to 0, 0, and 6. We'll adjust this later on when we talk about colors. Next, we'll set up the SDF that will define the shapes in the scene. Initially, we'll use a simpler approach and then replace parts of it later on. Open the palette with Alt-R and create a Torus SDF, and then connect it to the first input on the renderer. On the Torus SDF, change the axis to Z so that it's facing the camera. Then increase the radius to around 1 and the thickness to around 0.5. What we want is to have a segment of this torus that's hollow so that we can fit smaller ones inside of it. Create a radial slice operator, and we're going to insert that between the torus and the renderer. This operator takes a slice of an SDF around an axis. Increase the angle width to around 150 and the center angle to 180. So that gives us a little bit less than half the ring centered on the bottom. Next, we need to make it hollow, but the Torus SDF doesn't have that option built in. So instead, let's create an onion operator and insert that between the torus and the radial slice. This operator gives us a hollow shell of the SDF. Note that we put it before the radial slice rather than after, because if it was after, it would be hollow, but the ends would be covered. Next, we'll create multiple copies of this shape nested inside each other. Create an instance operator, and we're going to insert that between the radial slice and the renderer. Increase the count to around 8. This gives us 8 copies of the shape, but currently they're all the same, so we can't see them yet. So we need to vary the thickness of the rings for each copy. Select the instance operator and open the Editor Tools menu with Alt-Shift-R, and then under Reference Variable, choose Normalized Index. This creates a variable reference that accesses the number of the copy scaled to a 0 to 1 range. Connect that variable reference to the thickness field input on the Torus SDF. Note that depending on the version of the toolkit that you're using, inputs may not be in the same order as you're seeing them here, so it's important to mouse over them and make sure that it has the right label. So connecting that to the thickness field input, we get something kind of like what we want there. But if you zoom in a bit, the inner one is really, really tiny. That's because it's getting a thickness of 0 since the normalized index is 0 for the first of the instances. So with the variable reference selected, open the editor tools with Alt-Shift-R, and then choose Rescale Field, and make sure to use Rescale Field and not Rescale as Vector. Connect the Rescale Field to the thickness input on the torus, and then we need to dial in the range of values. For the input range, we can keep that on 0 to 1, since that's the range that that variable is producing. But for the output range, let's set the output low, the first part, to 1, and then the output high, the first part of that, down to around 0.2. I'm intentionally swapping these so that the first copy is the outermost one rather than the innermost. It isn't strictly necessary to do that, but it makes more sense this way, at least to me. Next, we'll add some rotation to the shapes. The goal is to have the inner and outer shapes rotate independently and have the ones in between blend between those two rotations. Create an axis rotate operator and insert that before the instance operator. Make sure the axis is set to Z, and depending on which version of the toolkit you're on, it may automatically default to that. This operator is a simplified version of rotate that only goes around one axis, which is all that we need here. Go over to where we're controlling the thickness of the ring, and copy the variable reference and the rescale field, and paste a new copy of those. Then connect the rescale field to the rotate input on the axis rotate operator. Since we're dealing with angles, we need much larger values than what we were using for the thickness. Try changing the first part of the output low and the output high parameters. We'll add some animation to these later on, but for now, let's set them to -40 and 70. That spreads them out so that we can see the inner ones. Before we move on to colors, let's add some variation to the shape. Right now, we're basing everything off of a torus, but it would be nice to be able to blend that with other types of cross-sections, like polygons. We can do that by creating our own torus with revolve instead of using the torus SDF. Create a circle SDF. Then create a revolve and connect the circle to its cross-section input. Then connect the revolve over to the onion operator instead of the torus. And now we can delete the torus. Next, we need to move the cross-section away from the center to make a ring. On the revolve, increase the radial offset to around 1. This gives us a torus matching exactly what we had gotten with the torus SDF. This is actually how the torus SDF is implemented internally. It's just a circle swept around an axis. The radius of the circle is the thickness of the torus, and the radius on the revolve, the offset, is the radius of the ring. Now, to get the sizing of the instances working correctly, take the rescale field that we had been connecting to the torus's thickness input, and connect it to the radius input on the circle SDF. Now that we're making our own torus, we can mix in other 2D cross-section SDFs. So create a polygon SDF 2D and connect the rescale field up to its radius input. Then select both the circle SDF and the polygon SDF and open the Editor Tools menu with Alt-Shift-R and choose Blend Ops. Then connect the output of the switch to the cross-section input on the revolve. This created a new switch operator with the blend between inputs setting switched on and those two SDFs connected to its first two inputs. Now we can use the source parameter to smoothly transition from circle to a pentagon, or whatever shape we have the polygon set to use. For now, I'm going to set this to 0.5 so that it's somewhere in between the two. There are more things that you can do with this that I'll mention in the next steps section at the end. Next, we'll assign colors to the shapes using a sine wave mapped onto a rainbow spectrum. Create an assign color operator, and we're going to insert that between the radial slice and the axis rotate. Create a spectral color field operator and connect this to the color input on the assigned color. This operator produces colors based on light wavelength, using a few different types of spectrum. We can use the wavelength parameter here to go across the spectrum. So try playing with this and find a range of values that you like. So I'm going to go with around 0.25 to around 0.75. So now we need to have a wave that produces those values. Copy and paste one of the variable references that gives us that normalized index of the instant. Then create a wave field operator. And we're going to connect the variable reference to its coordinate input and its output to the wavelength input on the spectral color field. Then on the wave field, increase the offset to 0.5 and decrease the amplitude to 0.25. So this gives us that range from 0.25 to 0.75. Adjust the phase parameter to shift the color pattern across the instances. I'm going to leave it around 0.8. You could potentially animate this if you want, although we won't cover that in this video. We're currently using the default material, which in this case looks pretty good, so we can just leave it as it is. Let's adjust the light a bit though, so we get some more shading. So go over to our point light and increase or decrease the X part of the position to put it off to one of the sides. So I'm going to go with around 6, and then increase the Y part of the position to move it up. So I'm going to go with around 8. So that gives us a little bit of more defined shading on the bottom and the sides. The last step is to add our animation. We're going to keep it simple on this one, only animate the rotation. So let's go over to our axis rotate and the rescale field and variable reference that are driving it. With the rescale field operator selected, Open the Editor Tools menu with Alt-Shift-R. Under Animate with LFO, we're going to choose Output Low 1. And make sure to use that rather than Output Low, because that would animate all 4 parts of that parameter. We only need the first part. So that'll create an LFO generator and attach the parameter to it. So select the rescale field again. We can do the same thing again, Alt-Shift-R, animate with LFO, and this time we're going to do Output High 1. So these are the two ends of that range of rotations, for the innermost and outermost. So we're seeing a tiny bit of movement in there, but because we're dealing with angles, we need to have much larger values. So let's go to the first LFO, and under amplitude, let's change that to something like 70. Then we're going to change the wave type from ramp to sine. Next, we're going to switch off sync, which will detach that LFO from the timeline so that it runs independently, and we can use seconds instead of beats for the period. So for the period, increase that a bit to maybe around 12 or so. Doesn't have to be exact. And then we're going to do the same things on the other LFO. So go to the other LFO. For the amplitude here, I'm going to pick a different number, like 90. And then also going to change the wave type to sine, switch off sync, and then set the period to something different from what you had originally set on the other one. And this is because having these two that have different periods that aren't even multiples of each other means that it's going to vary smoothly over time, and it's rarely going to repeat because those two waves are rarely going to line up at the start. Alternatively, you could set them to even multiples of each other, like 6 and 12 or something like that, and that would cause it to repeat in a reliable fashion. And that's it for our scene. So to recap, we're creating our own ring shape using a 2D cross-section made by blending between a circle and a polygon. We're revolving that around the z-axis to create a full ring. Then we are using an onion to make that a hollow shell and a radial slice to take a chunk of it out. Then we are making multiple copies of that, and for each copy we're varying different properties. So the first part that we're varying is the radius of the cross-section SDFs, which controls the thickness. So having that go from a large value to a small value causes those to be stacked inside each other. Then we are doing something similar for the color, where we've got that index of the copy mapped onto a sine wave, which is controlling the wavelength for a spectral color field, which is giving us that kind of rainbow pattern. Then we're also using that index to apply rotation, and so we have a different amount of rotation for each of the instances, and we're animating the outermost and innermost separately, which is changing the range of those values that this index gets scaled to, so the ones in between get linearly interpolated between those two rotations. And finally, we are rendering that out with Raymarch Render 3D with a look-at camera and a point light that we moved up into the side a bit so we get better shading. There are a bunch of things that you could add to this. You could swap in different types of 2D SDFs. Just remember that they need to have their radius or size controlled by that rescaled index number, and that will make sure that they stay kind of stacked inside each other. You could also use a variable, the normalized angle variable in the revolve, to create like a wave field and use that for the index field setting on the switch. And that would allow you to have it be a circle in some parts and then kind of smoothly transition to a polygon and then to something else and so on. You could also animate the phase on the wave field to get that color pattern to kind of shift across the instances. I look forward to seeing what you all do with the scene. And if you do post on social media, use the RayTK hashtag so I can see what you're doing. If you want to support RayTK development, check out my Patreon. You'll get early access to tutorials, exclusive scene downloads, and more. Thanks for watching, and as always, make sure to like and subscribe.